This presentation is delivered by the Stanford Center for Professional Development.
All right, any questions administratively, things that are going on? I had one student come and hang out with me on Friday, and I had some of my staff members. So I'm hoping that was just because it was such last minute. You guys were all off skiing, doing something fun this weekend. But this Friday, I don't have a meeting, so put it on your calendars now for Friday hanging out. All right, C++ libraries. So the notion of a library is really nothing more than saying you've got some functionality that you want to provide to all users of C++ or all students enrolled in CS106. And that there is kind of some reasonable grouping to these things. You have a bunch of operations that operate on strings, or that allow you to do graphic works, or allow you to do event handling or something. And so the library is the packaging device in C++, where you say, well, here's a set of routines. Typically, it comes with two pieces. One is the interface or declaration or header file, we'll call that. And it tells you about what routines are in there. What are their names? What are the prototypes? How do you use them? You know, it often contains good comments about the things you would need to know as a client using that facility, how to use it effectively and correctly. And then there is the code that really implements it, that when you make the call to a substring operation, how does it actually work? Well, there's some code that backs it, that actually does the operation that gets called at runtime when you make a call to that function. The libraries that we're going to see this quarter form roughly two big groups, right? The C++ standard libraries, so things that come with every C++ compiler. So no matter where you continue coding in C++, you will always find things like the C++ string, the C++ IO stream, the file stream, which is the F stream. There's a math header. There are headers that deal with all sorts of other facilities that are kind of beyond what we're doing here, but these are the ones that we'll see most commonly in the early part are string and stream. The typical include for them is going to be the angle brackets. That's the sign to the compiler. We're looking for something from the standard header locations. And one way to remind yourself about how to distinguish these from our special libraries is that you're going to see these very terse and lowercase names. Kind of part of the legacy of C and C++ was as a professional programmer's tool, they tended to value kind of terseness over any kind of verbose and descriptive names, making it a little easier to type, a little faster to get your point across. So things like the cout, which is the console out stream, the get line, the substr call, there's the substring name of the function there, tend to be short, tend to throw away vowels where they can, tend to be all lowercase. So whenever you're looking at a routine, you might wonder where it comes from. If it has this capitalization scheme, it's likely to be something coming out of the standard libraries. In addition to what we have present in the standard, we also have about 7 libraries that we've included as part of just CS106, mostly to make our lives a little bit easier, to provide us some convenience. Things like the random library or the simple IO library, they actually layer on existing functionality that is already present in the standard libraries, but the way the functionality is expressed in the standard is just a little bit awkward or unhelpful for the kind of tasks we need to do, so we've provided a layer that kind of cleans it up for you. The graphics is a good example of where there is no graphics library included in standard C++. So if you're working on graphics on Windows, you have access to a different toolkit than you do on the Mac or on Linux or some other platform. We have try to abstract out a very simple graphics library, right, that we can run on both Mac and Windows that then we provide one interface through that actually in turn talks to your platform in its native language to make those windows and drawing things happen. So our header files are always in the double quotes, that random.h, and then we typically use the strategy of having capitalized verbose names. We don't throw air vowels. We try to make a little bit of sense. It tends to describe the action that's being taken, that draw a line, get an integer, and so on. So today what I'm going to look at is I'm going to look at one of the 106 libraries here at the beginning, just because it's a nice, easy one to get our head around. I'm going to go and look through the C++ string library. And then I'm going to hopefully get a chance to even start talking a little about the C++ stream library. And along the way, there'll be 2 additional 106 libraries that help out with string and stream that provide a little bit more functionality than what's already there. So randomness. comes up in all kinds of simulations in game playing, right, is that you want the computer to have simulate some random behavior, flipping a coin, rolling a die, or shuffling an array or a deck of cards. Computers actually aren't really capable of true randomness in the sense that you might think in the real world, but they have what's called sort of pseudo-randomness behavior, where it can generate numbers in a sequence that appears effectively random from the outside, even though there actually is some determinism in how it operates. There is a set of library, in our library there are exactly 4 functions that kind of form the cs106 random library that are used for all kinds of random behavior that you want there. I note here that they're free functions, and by free functions I'm meaning that functions that aren't on a particular class, they're actually just globally accessible. You don't call them by sending to a particular object. They actually just exist at the top level namespace, and you can just call them anywhere and anytime. When you're ready to get some random behavior, you make a call to one of these routines. There is an initialization routine for this library, the randomize call. That's called once and exactly once in your program, usually at the very beginning, to kind of set up a new random sequence. So that kind of what's called seeds the generator to get it started in a new place. And then once you've made that call, you can make intersperse any number of these calls to simulate certain random events. The standard random number generator that's in C++ kind of provides all of this through just one call. It's just like, well, generate me a random number from 0 to the largest number possible. And then you can decide how to map that to other things. Like if you wanted the ability to flip a coin, you kind of want to say, well, half the numbers are odd and half the numbers are even, or half are heads or tails. You could do something like, well, just generate a number and see if it's odd or even, or see if it's from the bottom half of the range versus the top half. That what these functions do is just kind of provide that functionality, kind of package it up for you neatly. So you can say things like random integer low to high. You say 1 to 5, it'll give you a number from 1 to 5 inclusive. And that is that if you keep calling that, you should see there's a kind of unpredictable sequence of the 1, 2, 3, 4, 5 coming in jumbled and mixing up. No real guarantees about what order you'll see it. That will allow you to kind of simulate random events. The random real, same sort of idea, but in this case using boundaries that are expressed in real numbers and returning a real number. Again, the bounds are inclusive, so it can actually return the number low or high or anything in between. And then the last one is simulating a probability sort of true-false value that given, let's say, the probability of 0.5, half the time it should return true and half the time it should return false. If you give it a probability of 0.25, so 1/4 of the time it'll return true and the other 3/4 of the time it'll return false. So it allows you to kind of simulate coin flips or other kind of random events where you have a probabilistic distribution you're looking at. So the point of kind of a library, right, is to take some set of facilities that are needed, package it up, kind of have a little bit of a vision for how they work together, a naming convention and a design convention that makes them kind of coherent, that they provide some convenience, right, and that they're complete. They kind of cover all the bases. So these three provide a pretty good range of different kinds of random events. And there's still other things you might need to simulate, but you can typically do it in terms of using one of these. You could also have kind of left one out and have to simulate the others from it. But each of them actually kind of has a client use that's pretty handy, so it actually kind of has all three of them for your use. And so that comes out of random.h, right, in the CS106 library. The what?
What is .h?
It is random.h is the name of the file.
What is .h?
The .h is actually just a convention for the extension for header files, like .txt gets used on text files and .cpp gets used on source files. .h is for header files, which are descriptions of kind of routines, but no real code typically is in the .h file. It's an interface file, they call it. So in Java, right, there isn't that distinction, right? Everything is all in one file. The definition of a class serves as both the description for a client using it as well as the implementer implementing it. In C++, those things are separated. So let me look at C++ string as the next example of something we have to make use of in getting things done. The C++ string type is actually defined in a header file, and it's a library that's added into the language. So unlike int and bool and double that really are kind of part of the language and really can't be separated from it, string is kind of an add-on that's defined through a library. It models a sequence of characters. And characters including everything, letters, numbers, digits, punctuation, All those things are characters. And the string is actually defined as a class. So in the same way that in Java you're used to the idea of the class being the pattern from which you can declare and initialize objects that then you can message and do things with, string in the C++ world is the same sort of deal. You have a string class, you initialize string objects, you send messages to those string objects to ask them to do things for you. Asking a string to give you the character at a particular position, or the number of characters, or to insert some characters or change some characters within the body of the string are all done by messaging the string. A couple simple operations. So I put a little bit of string code just to get started, right? The variable name is actually string itself. There's something a little bit different about string when you declare it and you don't initialize it relative to the things we know about primitives. That when I say string s and I don't say anything else, I have an s equals or any kind of initialization there, you might assume that then, similar to the primitive types, right, that s is just garbage. It has some sequence of characters, 10 characters, 20 characters, 2 characters, with garbage characters in there. In fact, actually, the string has what's called a default constructor, one that's invoked when you don't specify otherwise, such that when you initialize a string with no other explicit information, it will assume you meant to set it up to be the empty string. So making a call string s actually declares and initializes a string with no characters, kind of empty double quotes. So if I were to ask it for its length, which is the way we ask for the number of characters in it, right, that's being used right here, for example, s.length, and then close the open paren there, would return 0 on the empty string. We can use square brackets, like the array notation you're probably familiar with, to access individual characters of the string. So applying the square brackets to s sub I, sometimes I'll call this, right, access the ith character within the string. The characters indexed starting from 0. So if I have a 10-character string, they actually are indexed 0 through 9. And the C++ string, the square brackets allow you to access that character both to read it and to write it, to change it. So a C++ string is mutable. The Java string is immutable, that once you create a string, right, it has a certain sequence of characters, and although you can make a new string and overwrite that one, you can't go in and just manipulate the string in place and kind of change its contents. C++, you can do that. So I initialized string in this case to the string literal or string constant cs106, and then I ran a loop over the index of the proper range of indices for this string, and then I used the toUpper, which is a function from the standard C library that takes a character and returns its uppercase equivalent or unchanged if it's not a letter. And then it assigned s sub I the result of toUpper. So the effect of this was for each lowercase character in the string, we overwrote it with its uppercase equivalent, and any other existing uppercase or punctuation characters just got were left unchanged, right? So actually can make assignment right into that, which is something you cannot do in with the Java string. Question here.
Could you insert like between two characters?
I certainly can. I'm going to show you that in about 2 slides, but there's a whole set of member functions that then do these things like, so this one allows you to kind of just, given you have this sequence of 5 characters here, go in and mess with them. It's like, well, what if I want to put one in the middle? I'll use something called insert. If I want to take one out in the middle, I use something called replace or erase to pull it out and put something else in. Many of the built-in operators, so things like equals and less than or less than equal to, not equals, have extended meanings that apply to strings when they're used as the operands for those types. So I can assign 2 strings using equals. If I say string s equals t, as I'm doing right here, right, then whatever value t is the 5-character sequence hello, s becomes a copy of that. And now s and t have the same value, but they're not related in any important way going forward, right? We have 2 copies that both happen to have the same 5 characters. So, for example, the first thing I did after this was change the first character of t to be j. So now t is jello, s is still hello. So it was initialized from the same sequence, but they don't retain any kind of aliasing from that point forward. I'm able to compare 2 strings directly to see whether they're lexicographically equal or less than according to ASCII ordering. So I can say if s equals t. In Java, that didn't do what you wanted, right? It did compile, but it didn't test the thing you were hoping for. In C++, it does do what you're expecting, which is to say, take 2 strings and really say, do they have the same sequence of characters? So if I have assigned s to t, if I do s equals t, it's going to say yes, right? They have the same 5 characters in the same order. Once I've changed one of them, right, then they'll come up as not equal. I could do less than and less than or equal to see whether in ASCII ordering which one precedes the other, to do kind of sorting of strings. So just like you think of as kind of like the integer types in double types, right? Those operators have reasonable meanings applied to strings. The plus and plus equals, right, it's what's called overloaded, so extended beyond its usual meaning for addition to do concatenation of strings. So I can take S and I can add to it a character space at the end. So now instead of being just hello, it's hello space, right? I can also add strings to strings. So I can take T and I can use, let's say, the shorthand plus equals, which takes jello and turns it into jello jello there, attaching another one on the end.